Hello, let's play the Netflix puzzled Starstruck for June 13th. We'll do the easy, then the hard. Easy is called mitosis. All right. The way we play this game is in each row, each column, and each colored region, we're placing exactly one star. In addition to that, stars can't touch even diagonally. All right, so I'm seeing these two hugging, these two hugging. Basically, what we're seeing is that brown is going to place a star. Let me just draw this out because if you're not familiar with this, the visuals help. So in between these two lines, we have two rows. And each row has one star. So we're expecting to find two stars. But we know that brown is completely inside of these two lines. So it has to place a star. And green also has to place a star. That's both of our stars. So if you're not the brown or the green, then you can't have a third star. You would be a third star. Same thing for these two verticals. Yellow and orange are going to do it, but also orange is just down to these two. So that just uses up that column. And this two cell region that's left, that's something to know about. Because of the no touch rule, we can't do these two because if it was here or here, it would be touching the star that ends up in one of these two. And that places the yellow, which places the orange because of the no touch rule. This top row is going to have indigo. That's fine. We knew that from the start, but I saw lower hanging fruit. We have these. Oh yeah, this column here is only indigo though, and then we can place it. So this star was given at the start because this row and this column were only indigo. So the only way to avoid two stars, one in this row and the one in this column, is to place it where they intersect. Okay, so now the green's one of these two. That removes the rest of the row, but also this one because it touches them. So that gives us the brown, and that gives the green. We get the blue, we get our red, and we're done. All right. Cool. That was a nice easy there. Let's do the hard. It's called shrug. All right, I was going to say we had the same trick, but this loaded last. So this is a star. Now the top row is going to be indigo, so we're going to get rid of the rest of indigo. What's next? This blue eliminates quite a few because this touches them, this touches them. I guess quite a few is two, but those all see all of blue. Interesting. There's something weird here. Like I'm seeing like I don't know how to draw this. I'm seeing this almost line up. Okay. This is interesting. So we know that at least one of these has to be true. Just to start out with, because brown is going to use one of our stars. So we only get a second, at least we only get one more star here if we're going to use one at all. And so, but this is two different regions. And so we'd have to place one here or one here. But both of these look up and would force a star here or here. So they can't both be true. So we get a few deductions here, which is one of them is true, which will place a star here or here, meaning these can't be stars, which then these two are moved from here. But also, since they can't both be true, we know that there's one in here also, and that's going to line up with these two in the brown, removing those. Very cool. All right. I'm going to clear this. So now we know that one of these two is in and one of these two is in. So it's either these two or it's these two, though. It's linked this way, which is a more unfortunate result. It does mean that this is never in and this is never in. Because it's either this and this or this and this. Which also removes that one. And it removes this one here, for what it's worth. Okay, so yeah, because this sees that one and that one. That's always going to be true. And so now if you look at this row, it's only blue and gray. Yeah, I don't know that that's helpful, actually. Okay, so what's next? Oh, since one of these two has to be in, these two are out. Okay, that's what I was missing. I don't. So now one of these two must be in because of the lineup that we talked about, or this thing. So these are out. Okay. This one actually touches all that's left in yellow. Is there more to this? So, I don't know, what can I say here? We know that since only one of these is in, we know that either this is in or one of these two is in, which does eliminate from here. But more importantly, it lines up with red. And so these two yellows can't ever be true. Oh, and we could have just seen that more easily by looking at this row. Oh well. It is what it is. I see it the way I see it. Um, I kind of feel like you could use. Am I doing this right? Yeah, like if we take these three columns, you can see that we almost have. I mean, we definitely have yellow. We definitely have green. We almost have red. Now, but we could include red by taking this column here. And so now that's going to be four. Three from here and one from here. That's going to be four. But we know that red is going to have the third one now because it's fully covered. But where's the fourth one for these four columns? One, two, three. Where's our fourth one? It's not in between, right? It's not these. And so the only color left is indigo, I believe. Right. And so that eliminates these two indigos. And so now if we look at these two columns, this is really interesting. If we look at these two columns, we have to place an orange and gray. And so gray has only one choice. That gives us the orange. That gives us the green and the red. The blue, the yellow, the indigo, and the brown. Wow. Okay. So I think that was correct logic. Hope it was. That was neat though. You almost never get to use like disjoint columns like that, but it works the same way as using ones that are next to each other. It's just less common to spot that kind of thing. That was neat. All right. Well, how'd you do?